disturbance.
Okay, so
So
this is
this
average
is
Sheet 1 total revenue. Okay. What is the difference between the average calculation by using row wise and filter wise?
in row wise, we will try to get the average of each item code, but total average will give us the total for the total average for it.
So now I would suggest to have the row wise calculation. So in that case, what will the DAX code?
This is the total. If you wanted to. This is the answer.
What is the measure we have used here to calculate the row wise?
Sir, I have taken the quantity of unit measure and I have found that average revenue for.
Okay, but what is the method? This is actually, you're creating a table here, right? What you're doing is you're
Yeah.
creating a table and you're putting the average, and what there is no relationship between the unit of measure and the average revenue. We have to
Okay.
find the average revenue for the item code or item description, not for the UAM. So in that case, I will ask you to find the measure for average revenue for row wise. So have you heard about the formula called calculate?
Yes.
You use the calculate function and you find the average.
Not able to get it.
What is the need of doing a divide here?
So trying to find out row-wise average calculation.
Then why we need to do divide here? If we want to use divide, then we have to use sum divided by count. If you do not need to, better is to avoid divide because we have a direct formula for average. We have a direct formula for the average.
Okay, sir.
If you better is to avoid divide because we have a direct formula for average. Okay, write the formula. Remove everything from there. Just after equal to remove everything other than calculate. Other than calculate, remove everything. Okay, now put the calculate. Opening bracket. Okay, what is the expression we want to use? We want to use expression for average, right? Don't give any space there. Average, yeah. Click on average. Now what we want to do? We want to find the average total revenue, right? Sheet one total revenue. Select sheet one total revenue from the drop down list. Yeah. Right. Close the bracket. Enter. On the right hand side, if you look at the field list on the right hand side, where we have a table, our table sheet one, right? Sheet one. If you see the first one, the first line or the first variable, you see average revenue. Right? This is what we calculated right now. And if
Okay,
you
sir.
and if you look at the sign of a calculator there, this is sign of calculator, that is called the measure. No, not below that. Yeah, because that is a sign of the calculator, right? We have a sign of calculator there.
Okay.
If you look at there, if you look at this, the sheet one, the list of variables, the first variable is average revenue, just now which we have calculated, and the symbol symbol next to average revenue is calculator sign. Can you see that average revenue next to average revenue? Not there, but on the sheet, in the field, within the fields, the variables, right? And if you look
Right.
at invoice data, the invoice data is having a calendar sign. It is means this is a data point which is having a date date format. Right?
Okay, sir.
So wherever you see, I think the row wise, that is what you have to delete because that is incomplete. The row wise which you have, that in sheet one, that select that and delete that. If there is checkbox next to that, yeah, you can delete this. Delete from the model. Right. Now I've asked you, this is what we have done now. Now we have to find a new measure now. The new measure is that I want to find the median. Again, we have to find it row wise. And this is median.
So row wise means it's average.
No, row wise means you're trying to, we will be focusing on item wise. So if you have, suppose in case if you want to find the average by item wise, so then in that case the the row wise calculation will help. But if you want to find the average for the entire data, right? Want to find the average for the entire data, then you have to use the formula average. But if you want to find the data for item wise, suppose if you want to apply that calculation item wise, in that case the row wise calculation will be helpful for us.
Okay, sir.
Now we'll find median. So again, you have to go to new measure and we want to find it the median for the item wise. So you have to go for row wise. So what is the formula you're going to apply?
Row wise we have to find the average of the
No, I'm asking you to find the median now,
median. Okay.
not the average. Average we have already done, right? We are done with the average now.
Median or item code, sir.
Item code? No. Simply median, right? Again, same thing. Calculate median. Then you have to go to median for the what? Total revenue.
We have to find.
We have to find the median of the total revenue. So again, you have to go to sheet 1, total revenue.
Okay, sir.
Close the bracket. Close the bracket. Enter. So now if you see, we will be, I think you have to give the name for this particular measure, that is median. Okay. And select.
Okay, sir.
And enter. After entering, I think you can see on the field list in the sheet 1 table, you can see in the field list we have median there.
Yes, sir.
Table, you can see in the. Okay. So now after doing median, we'll find the mode, MODE, mode. New measure.
Mode of total revenue.
Yeah, I think spelling is wrong. The mode spelling is wrong. It is MODE. You're not happy to, there's no mode in this?
No, I think so. There is MOD only.
MOD is not. Mm-hmm. No, it's not there. The expression is not available. Okay. Go to just open your Google once. Open your Google and write there mode in MODE, mode in Power BI. The first one, Power BI DAX, second one. Click on the second one, the calculating mode of a measure. Yeah. Go to just come down. Go to mean is there. Okay, there is a formula we have to write for this. Okay, no problem. We'll find the mode later on.
Okay.
Okay, now let's go to next formula.
Okay, sir.
We'll find the revenue is there, right? We have found the average, and okay, we found the average. We found the median. Now we'll subtract the median minus mode. We have find two measures, right? Median and mode. Now we're going to subtract both of them.
We have median and the average.
Yeah,
So
median
what
and
is
average.
what?
Yeah, so median and average, we found it. We'll subtract both of them. So now next function is subtraction. Mean minus mode. Just write the name, mean minus mode.
Median minus average.
Yeah, median minus average.
But there is no subtract here.
No, we don't need calculate here now. We don't need calculate.
Okay, so we can do directly measure wise.
Direct, yeah.
Both.
Yeah. Because both the measures are already row wise. Subtract, yeah, fine. Yeah, click enter. What is the name of the median minus median? Okay, we got it. Okay, so next function we will use is percentile.
Okay, sure. Okay.
Percentile.exe. Okay. Now we'll again use that sheet 1 revenue. Too few arguments. Okay. Once again, remove this. We go to percentile.x. Percentile x. Yeah, percentile x. Yeah, percentile x. Now remove all the brackets. Just keep it simple. Okay. No, why we have comma there? Yeah, just click on percentile x. If you see the bottom function, and remove the calculate function also. Yeah. Now go back, remove the opening bracket and put once again. And put again. Double click on the below one. Yeah. What is the first thing they're asking? The table.
But sir, this is add column.
Oh, why are we getting add columns there? Remove that. Yeah. Now remove the bracket also opening. Yeah. Okay. Now, yeah. Now what is they're asking? Table. Table is sheet 1. Sheet 1. Yeah. Comma. Yeah. Percentile.ex. Yeah. Again,
column name would be total description.
Total revenue. Comma. Comma.
It should be
0.25. 0.25.
0.25. Okay, after decimal.
After decimal. Yeah. Close the bracket and one more closing bracket. Two closing brackets required. Yeah. Enter. I think the last bracket is not required. The last is not required. Remove the last bracket.
Last one.
Yeah. Enter. I think we have to remove the last bracket, right?
Yeah, sir.
Yeah. Enter now.
I think, sir, I have entered it.
So too few arguments were passed to the percentile dot
So we have to pass this also for this we have written part for this values here. So we have passed this to 0.25 for this percentile, but not
Do
for
one
this
thing,
percentile.
remove the percentile dot x, the before, yeah, remove the first part before percentile, yeah, remove that part,
This one
yeah, remove that part, remove the part, yeah, remove that from up to sheet 1, remove the,
up to sheet one.
yeah,
So this one, sir.
no, before the first part, the first half, there are two percentiles, yeah,
Yeah, sir.
no, remove, keep that one, remove the first half,
Okay.
yeah, remove that one,
First one. Okay, sir.
even sheet 1 also you remove.
Sheet also. So, okay, sir. Now, yes, sir. Now it's complete.
Okay, so percentile.ex
Yes, sir.
sheet 1 total revenue 0.25. Now similarly, this is give a name, the name should be 25 percentile, 25th percentile. So change the name,
So,
change the
okay,
name,
sir.
the name, right? Yeah, make it
Yes, sir.
25th percentile.
25th percentile. Okay, sir.
Now similarly, now find 75th percentile.
Okay, sir. Yes, sir. Okay, sir.
25 percentile, yeah. Now subtract this 70th percentile to 25 percentile.
Recording in progress.
Sharing the screen, sir.
Yeah. Now we will subtract the 75th percentile to 25th percentile.
Yes, sir. Sorry. Start my share here. It is percentile. See, but it seems to be like said the percentile that we have created for 25th and 75th. It is not showing inside the field section.
I think what you have done is that you did the overwriting, right? You had a formula and you did the overwriting on that. So there is a problem with both the formulas. Now just check. There is a problem here also. I think
Okay,
you are
so
overwriting the formulas.
okay, so sorry,
Rem-
sir, I'm trying to fight damage.
remove this, remove everything, and go to click on 75 percentile on the right hand side on the field. Go to field list. Go to field list. Go to field list. No, no, field list on the right hand side, right? Double click there.
Yes, sir.
Double click
Right,
on
sir.
75 percentile. I think you have to remove the formulas also. I think you have to rewrite the formulas, right?
Okay, sir.
Just rewrite the
Okay.
formula. Click on that right means right sign. Yeah, click over there.
That's just one minute.
Okay. Now what you have to do is that delete this. Okay, I think you can write there still. Yeah, delete that formula. 75%.
So should we delete this
Yeah,
and try it
delete.
again, sir?
Yeah. First, you have to find 25 percentile, 25th percentile.
Yeah, sure. Okay, so we have to every time make it a new measure here.
Yep.
Okay, sir.
So now we have to find new measure, and the third measure we have to find the subtraction between the 75th percentile and 25th percentile.
Okay, sir. Just not take that measure. 875 measure minus sheet 55 measure. Minus 75. Okay, sir. Sure. Right, this is complete.
Okay. So we are finding, what we're doing here is that we're trying to find our measures, right? We first found our median, we found our mean average, we found 25th percentile, we found 75 percentile, we found 75 minus 25th percentile, right? Now we'll find 95%, 90 percentile, 95 percentile, and 98 percentile. Okay, now let's find three more percentiles: 90, 95, 98.
So we have to create the 95%.
First 90, first 90, then 95, then 98. And we will know why we are finding all those things after we complete this, and we will go into the analysis that why are we finding this kind of numbers, and what is the purpose of what is the use of these numbers in the inventory management. So you're able to understand the formulas, right?
Yeah, sir. I can read it. So it is finished.
This is 98 percentile, right? So 90,
Yeah.
95, 98, right?
Right.
Okay. So now we will find the sum of revenue row wise. Sum of revenue row wise. So we have to find sum of revenue row wise.
For each item, right? This is a direct conversion.
Yeah, we use calculate sum. Yeah, fine. Perfect. Okay.
Okay, sir.
Now we are going to find a new diamond, new measure that is called standard deviation of total revenue. That is also row wise.
So row wise means per item wise, right?
Yeah,
sir?
per item wise.
So we are not mentioning per item there, sir. We are mentioning total revenue, sir.
Yeah, total revenue you're mentioning, but that is, if you use a formula like calculate and all those things, that will automatically will calculate, when we put the tables. When you put the tables, then it will automatically populate item wise.
Okay. So it's like a table that we have created for sheet 1. It will be populated item wise.
Yeah, wherever we have, calculate, we have used calculate function, it is going to be row wise. Wherever we are using calculate function, it is going to be row wise.
Okay, sure.
Now let's find the standard deviation row wise.
Standard deviation.
Yeah, this is stdv.s.
Not F. Okay. We have to find total standard deviation of the
Revenue, total revenue, sheet 1 total revenue.
run. Okay. Yes, sir.
Done. Now,
Right, sir.
now the next function, the next measure is you have to divide this standard deviation by average. This is called coefficient of variation. Give a name, coefficient of variation.
Okay, sir.
Okay. Now we'll divide. Use the function divide.
Okay. Right.
Standard deviation. Standard deviation, which you have found just now. We have found, right? What is the name of the measure?
Yes. Standard deviation. Sir.
Standard deviation divided by comma.
Comma, sir. Okay.
Yeah. Now average.
Denominator, sir.
Denominator is average.
Okay, so average revenue, right?
Average revenue. Close the bracket. Okay.
Yes, sir.
So
Right, sir.
I will like to share my screen and I will tell you what we have done, why we are finding this.
Okay, sir.
So whatever we have done, this is all the statistical measures.
Okay, sir.
And these are very powerful tools or techniques which we are going to apply in inventory management.
Okay, sir.
Able to see my screen?
Yes, sir. Screen visible, sir.
Suppose we have a data 20, 10, 100, 2, 2000, right? 18,
Okay, sir.
500, right? This is the data we have. And if I want to plot this data in a Cartesian, means in a two-dimensional path, the first will 20, right? The first is 20, let's say here. Second is 10, is over here. Third is 100 over here. Fourth is 2 over here. Fifth is 2000 over here. Right? Next is 18 over here. And last is 500 is something will going to come here. If I join these plots, so what we see this graph, this is this there is a variability in this graph, variation in this graph,
Right, sir.
right? So this variation which we see, if we have high variation, what is going to happen? If you have high variation, okay, and I'm asking you to predict what is going to happen next. Here, in the next cycle, what is going to happen if I'm asking you to predict? Can you predict accurately? By looking at the history, this is our history, right? These are a history.
You're right, sir.
By looking at the history, I'm asking you to do the prediction for the next sequence. What is going to happen over here?
So there is a trend that we are following, and this is the upper and lower trend, sir.
Upper and lower, right? We can just go for two, we may go for 100, right? But it can be 2 also. We are predicting 100, but it can be 2 also.
Right, sir.
So when we have high variation, the prediction becomes tougher. So to measure how much variation we have, there are two metrics for that. One is standard deviation. Three metrics we have. Second is coefficient of variation. Are you getting a point? Why we are measuring this?
So when we're trying to measure the variation, so these are the three methods that we will use. Sir.
Yeah, there are many other, but this is the most popular, right?
Okay, sir.
And third is mean minus mode, mean minus median. Or we can also do mean minus median by 3 into median. Or mean minus median by 3 into mean. Right? So one of them we can use. So, so let's see what is standard deviation. Standard deviation is a measure of variation. Suppose if I find the standard deviation for this, right? Let me find the standard deviation of this. We can do in Excel also. So let's say this is 20. Now what is it? 10. Next is 100. Next is 2. Next is 2000. This is 18. Then 500. Right? This is our what? Data point. And I want to find the standard deviation of this. So stdv.s. This is my data.
Okay, sir.
So 736 is my standard deviation. So what is the meaning of this? Its meaning is that this is an average deviation. If I do a prediction of 20, I might go either 20 plus 7. What is the meaning of this? If I make a prediction of 20, my prediction could be either 20 plus 736
Oh, 730 and minus
or
27.
20 minus 736.
Okay, sir.
If I make a prediction of 10, it could be 10 plus 736 or 10 minus 736.
Okay, so the news poll like that predicted that like that. So
Yes.
opinion.
Right? If I make a prediction of 10, it could be either 20 plus 736 or it could be 20 minus 736. There's a huge, and what happens is if this gap is smaller, then it is good. Right? If I make a number, like if I make 22, suppose if I do one prediction and it comes around 720 to 736. It's a very good prediction. Which means the gap between the lower value and upper value is very less. But if the gap between the lower value and upper value is very high, suppose if I say this is 20 and 756, it's a very big gap, right?
Right.
So it's a big gap means we have a very big scope of getting a number, and that number could be either lesser number or could be higher number.
Right, sir.
If I make a prediction of 25, the actual number could be around 700 also.
So, but then inside the after minus sign, then 20 minus 760. It will
No, it's not
become
minus.
positive,
This is
right?
22. Not minus. 22 to 756. In between that,
750.
this is a range.
Range, sir. Okay, sir.
It is not minus. It's a range.
Sir, so this 20 and 756 we are calculating by subtracting the standard deviation
And adding.
by taking the number and adding and subtracting it.
Correct.
Okay. And the result of this will be should be lesser as compared to the other ones. So should be lesser.
So what we want is range to be smaller. We want this range to be smaller.
Okay, sir.
Suppose if you have a range 720 to 756. This range is very small range, right? If I make 720, 730 is prediction. Even if 750 also is not a problem for me. The difference is very small. अगर मेरा 720 और 756 के बीच में मेरा रेंज आता है, मैं 730 भी अगर प्रिडिक्शन करता हूँ, 756 आता है, एक्चुअल में क्या होता है 756 होता है, तो गैप बहुत कम है ना सर. मैंने क्या किया, मैंने प्रिडिक्शन किया 700, आई डिड प्रिडिक्शन ऑफ 730 एंड एक्चुअल रिजल्ट इज 756. The deviation is very small then, 26 units only. Because I know that I can make a prediction between any number between that, and even if my prediction goes wrong, the gap between the actual value and the prediction will be always smaller. But in this case, if I make a prediction of 700 and if I get the actual, how much? 50.
720 minus
700 minus 750, almost a gap of 650. This is a huge error. My range is how much? 20 to 756. That's my range.
Right, sir.
And if you make a prediction of 700, I'm making prediction 7 because this number comes. ये जो number है 20 और 756 के बीच में आता है.
Right, sir.
तो मैंने I have made a prediction because this number falls in between 20 to 756, and this number
756.
I can make a prediction.
So,
This is acceptable.
this is the 650 is a deviation, sir.
Yeah, because now my actual is 50. I made a prediction 700, but the actual result came as 50.
Okay, so we have made a prediction of 700 and we have calculated deviation. It has come to like 756, sir. And we will try to subtract it plus addition it with that number. And the range that comes, the small one, we will try to keep that deviation, sir.
No, see this. When suppose you have a number, right? This is, let's say 20. 20. Okay.
Okay, sir.
Now I'm going to find lower range, lower value of the range. Okay, and upper value of the range. Okay. So what is the lower value? 20 minus 700.
56.
736. This is our standard deviation.
Okay, sir.
20 plus 736. This is our standard deviation.
Right, sir.
So this is our negative value. Let's say this is 0.
Yes, sir.
And this is 756.
Right, sir. 756.
So this is
It's
my
a huge gap, sir.
this is my U gap, right? This is U gap, and this is my range. 0 to 756 is my range.
Okay, sir.
And I have to, from this range, I have to make a prediction.
Oh, no, it's very difficult then, sir.
Very difficult. If I make a prediction from 0 to 756, let's say I'm making a prediction of 600. Right?
Yes, sir.
I'm
And
making-
actual is
Actually, let's say actual is 200. So 100.
okay, sir.
Then what is the gap?
Is 500.
500. The gap is 500 is a gap. It's a big gap.
Big gap, sir. So what's the minimum gap that we wanted to put it here, sir?
The minimum gap, we cannot put a benchmark, but the minimum gap has to be as less as possible.
Oh, okay.
If you want to have the minimum gap, what you need is that the range, the lower value range, the range of lower value, and the upper value range, right? This has to be smaller.
Right.
Suppose this is 600, this should be 700. What is the range now? 600 to 700.
Right, sir.
So if you make
prediction
a
can be-
prediction 620, if you make a prediction 620 and the actual is 650, what is the gap?
So
30.
it is 30.
30 is a small gap.
Okay, sir.
So if you want to have a small gap, then your lower value range and upper value range gap should be smaller.
Okay, sir.
So if your probability of getting a very low, high accuracy, low error, if you want to achieve that, what you should achieve? You should achieve the lower value of the range and upper value of the range. The gap between them has to be as small as possible.
Okay, sir.
Okay.
Okay, sir.
So now, standard deviation. What is standard deviation? The average gap, right? Average gap between a number to the average. Suppose this is an average of
Okay.
this is the average of the data. Okay.
Okay, sir.
So what is the gap between these two?
Predicted, actual minus predicted. Actual was 20 and predicted was
If you want to find the average of this number, let me do those also for you. So this is our data point. Okay. So this
Okay,
is
sure.
this is a data point, and we will find the average of this data point. This is the average. Click F4. So we got an average of 378. And what we're doing is we're finding the gap between this number to the average. Okay. Then what we will do,
okay, sir.
we'll find the square of this number. Square of this gap. Whatever gap we are finding, we find the square of that. Then we will do square of each and every gap. Then what we will do, we'll do the sum of this all gaps. Sum of the square of all the gaps. Then what we will do, we'll find the average of this gap. So how many numbers are there? 1, 3 plus 3, 6, 7. Now we'll do square root of this. Square root of this average. 682. Or if we suppose this is use 6 by 6 because sample, right? Yeah. So what is the standard deviation here? 736.
You're right, sir.
And what is the number you're getting? 736.
736.
So this is a gap, means this is an average gap between this is an average gap between average to the numbers.
Okay, sir.
Okay, standard deviation is nothing but the average gap between the number the numbers and the average of the numbers. This is the standard deviation.
Okay, sir. So these are the two methods to calculate the standard deviation like that one.
This is manual nature. This what I did here is this is a manual method, and this is the formula, Excel formula. Directly, we don't need to do all the process. Just we can put the Excel formula and we can find it.
Okay, sir.
But can you tell this deviation is big deviation or small deviation by looking at this 736?
This, sir, yes, sir. Because by looking the value of it, we can able to get lot of error in the prediction part. So because the range between two of them is very high.
See, if you, by looking at the number, you're saying it's a very big number.
Right, sir. 736.
Just a minute. Hello.
Okay, sir.
Hello. Okay. So now what I'm going to do is that I'm going to divide this standard deviation by the average.
Okay, sir.
That is what we did in the coefficient of variation. This is coming around 1.94. What is the meaning of 1.94? 1.94 means our standard deviation is 195% of average. COV, what is the formula for COV? COV is equal to standard deviation by average. Right? This is what we've done in the Power BI.
Right.
Now, if I say, what is standard deviation? Standard deviation is equal to average into coefficient of variation. Hello.
Yes, sir.
So what is standard deviation? Average into coefficient of variation.
Okay, sir.
Because COB is equal to standard deviation by average.
Which and so standard deviation is multiplication. Right, sir. Okay, sir. So this is the formula, sir. Coefficient standard deviation divided by average. Sir.
Yeah, this is a formula for coefficient of variation.
Okay, sir.
Okay, now what is standard deviation?
So it should be coefficient into standard deviation. Oh,
yeah,
sorry.
Coefficient into average.
Average, sir. Okay.
Okay, so what I want is ideally the standard deviation to be smaller than the average. We want standard deviation to be smaller than average. This is an ideal scenario. Okay, this is ideal. And if the standard deviation is more than average, right? This is not an ideal scenario.
The coefficient, what does it indicate here, sir?
Coefficient means factor. Suppose if my standard deviation is 40 and average is 80. So what is this? 1 by 2, 0.5. Right? What is COV here?
Right, sir.
COV is 0.5.
5. Okay.
So what is the meaning of this? 0.5 is equal to standard deviation by average. So what is standard deviation here? 0.5 into average. So what is the meaning of this? Standard deviation is 50% of average. That's what you're getting, right? This is standard deviation is 40 and average is 80. So standard deviation is 50% of average.
50%, right, sir.
So this is what we want. We want the standard deviation to be lesser than the average.
Okay.
Right? But how much we got here? In this case, how much we're getting? 195% means it is almost 2 times.
So where we are comparing this 195% to? So where, sir?
So if you look at here, the standard again COV is equal to standard deviation by average. Right? This is a formula. What is standard deviation we got? 736.
Right. sir.
What is average you got?
195.
No,
Sorry,
no.
if here, sir.
Average is on 378. 379. Okay. This standard deviation is almost 736. Average is almost 379. If I divide this, I'm getting 1.95.
Okay, sir.
So what is the meaning of this? COV is
Factor.
COV into average, right?
Right,
What is
sir.
COV here? 1.95
1.95
into average.
into 37.
Into average is equal to standard deviation. So standard deviation is 1.95 times the average.
Okay, sir.
This is very high value because we want standard deviation to be lesser than 1.
Because we wanted, so the perfect scenario will be, sir, what should be a perfect scenario if the standard deviation is less than the average?
Yeah, if it is less than average means, suppose this is standard deviation is equal to 1. Average is equal to 1. Now what is COV? 1 by 1?
One, sir.
1. If standard deviation is 0.9, okay, and average is 1, then what is COV? 0.9 by 1? That is equal to 0.9.
Divided by 0.9, sir.
So what we are saying is that if the standard deviation is smaller and average is bigger, right?
Smaller and average is bigger.
Yeah,
Okay, sir.
this is what we want. Standard deviation smaller and average higher.
Bigger. Okay, sir.
This is an ideal
This is the
condition.
perfect scenario.
Perfect scenario.
Okay, sir.
If the reverse happens, if average becomes smaller, standard deviation become higher, then our coefficient
Okay, sir.
means our variability is very, very high.
Okay. Sir, what is average denoting here, sir?
Average is a central number. Suppose we have data, right? Central
Right.
number. We have what? If you look at here, this is what the graph. See, this is central number, right? Average central number.
Okay. So for out of these all numbers, if we wanted to find any numbers, we will take its average, sir.
Not any number, central number.
Oh, okay, central number. Okay, sir. So it can be, but sir, central number, if you wanted to take a central number of these numbers, so we will use average. So if we wanted to, yeah, but condition is also like we don't want to take it from the upper one and we don't want to take it from the lower one. We want to take the central one.
Correct.
For this case, right?
Not all the case. If you want to find, there are many methods, many algorithms are there. One of this is the most popular algorithm. If you have a data, take a central number and then take standard deviation. And standard deviation is also is the average deviation between the numbers and the average.
Okay, sir.
Right?
Okay, sir.
Standard deviation is the
Yes, sir.
average gap between the numbers and the average of the numbers.
So my mother is calling. Give me 1 minute, sir, please.
Now let's close now because we already have gone.
Okay, sir.
We'll meet tomorrow then.
Okay, sir. Okay, sir.
Okay.
Recording